Hello and welcome back to another episode of Math with Sohn. Today we are going to be learning about my favorite triangle center, the centroid. I think it's just because it's fun to say, but let's get into it. The centroid is different than any other triangle center. The centroid has no congruent triangles in it, so that's very important to remember. So that means that even though point P is the centroid, D to P is not going to be equal to P to E, even if it looks like it. Nothing is going to be equal except for the parts that are actually labeled here. A to F is equal to F to C. And that is because the centroid is formed from the medians of every triangle. From every side of the triangle. So the median is formed by taking the midpoint of the side and going directly to the angle on the opposite side. So if you take this middle point and go to the angle on the opposite side, that is the median. So we found the middle, and then we go straight up to the angle on the opposite side, or the corner on the opposite side, we get the median. Okay? And if you take the three medians of the triangle, you will get the centroid. Technically, once you actually get two medians, you have the centroid, by the way, because anytime you have two lines intersecting, they're going to be the centroid. So you don't need all three. You could use two if you wanted. All right, we're going to first list the medians on this guy. BF is a median. It's going from the side, the middle point, to the other angle. So BF is one of them. AE is another one of them, taking the side BC, going to the middle, and going straight over. I don't know why I wrote B. A to E. And DC is the last side that would be having a median right there at DC. Point P is the midpoint. Okay? So, the medians, they have something special. I told you there are no congruent triangles in here. No triangles are congruent. However, there is a special relationship between these medians. If you were told that B to P was 10, P to F would be 5. Okay? So, that means that there is a few special relationships here. That means that if you double this short part, it would equal the longer part. Okay? So 2 times the short part would equal the longer part. At the same time, 3 times the short part would be equal to the entire thing. So the whole way across. Because if you took 5 and multiplied by 3, you'd get 15, and that's all the way across from B to F. And I'm calling PF the short part because it's visually shorter, and it is going from the side to the median. Side to the centroid. Okay? So the special property that exists is there's a relationship between that. And that relationship is important to identify. Now, if you don't like to think of it as short and long, you could say 2 times PF would equal BP. And you could also say 3 times PF would equal all the way from B to F. And I just focused on this one median. That is true with all of the medians. So if A to P happened to be 20, P to E would be 10 to make that half of A to P. Okay? So the relationship works with every single one of these medians. Let's do a few practice problems and see what it looks like. So, if point P is the centroid, okay, good to know, and JK is equal to 22. JK is equal to 22. That means this whole side right here is 22. And K to N is 13. And O to L is 18. We're not asked to find any of the medians here, I don't think. Let's just see what we can do with this. So if we want to find K to M, we do know that the centroid is found by cutting each side in half or taking the midpoint of it. So that means that MK is going to equal M to J. And if we wanted to find Km, we would just have to take 22 and cut it in half, which is 11. What's the next one? ln or NL is going to be 13 for the same reason. We did divide every side in half. K to L, well, if both of these are 13, that's going to be 26, 13 plus 13, or 13 times 2. JO is going to be 18. And JL would be 36 from the 18 times 2. Okay, so that one just focused on the outsides of the centroid. This next problem is going to focus on the insides, or the medians, of the centroid. So we are told that T to Z is 60. Okay, that's the longer part. So if I wanted the shorter part, I would have to half it. The short part is half of the longer part. So let's see what that is. That is ZY is 30. We are also told that X to Z is 28. Is X to Z the short part or the long part? Well, X to Z is on this midpoint. X to Z is visually the short part. The short part goes from the side to the centroid. The long part goes from the angle to the centroid. So I'm going to have to double 28 to get ZV. ZV, if I double it, I'm actually going to draw a line and go like that to say that that is 56 from doubling 28. So Z to V is 56. WZ is 25, and that is the short part. If I double WZ, the 25, I'm going to get the longer part is 50. And now I feel like I have everything I can to fill out the rest of this. What is Z to U? We just found it. It's 50. What is T to Y? Well, T to Y is 3 times the short part, or you can add 60 and 30 together to get 90. And X to V would have to be 3 times the short part, so you could either do 23 times 2, 28, I said 23, 28 times 3, or you can add 28 and 56 together to get XV. So whatever 28 and 56 is, or 28 times 3 is, I'm going to do 28 times 3 to get 84. I could have also added 28 and 56 because that also equals 84. All right? So, what I have here on this next problem is still the centroid. I have divided these sides in half. I eyeballed it, sorry. And I've divided these two sides in half as well. And where they intersect is the centroid. I did divide this third side in half. If I were to go through here, it should go perfectly through that centroid as well. And it does. Okay, so this point in the middle is the centroid, but you really only need 2 of the medians to achieve that. And what I want to do on this next problem is I want to establish how to deal with it if it's not just numbers. Okay? For instance, what if I was told that this part is 2x plus 4 right here, and I wanted to find out that AB, if I knew AB the whole way across, if AB the whole way across was like 16x minus 5, and I wanted to figure out what x was. Now, in this scenario, we're going to have to realize the special relationship that is here and the entire way across. So the special relationship is that if you take the short side and triple it, you get the entire thing. It is the short side times 3 equals the entire median. So I will have to do 3 times the 2x plus 4 to equal all the way across, and all the way across was 16x minus 5. And then I have to solve that equation by distributing. We get 6x plus 12 is equal to 16x minus 5. I am betting this is going to be a decimal. Do not judge me. Subtract 6x. 12 will equal 10x minus 5. Add 5. Add 5. 17 would equal 10x, and when we divide 17 by 10, you get 1.7. So at least it's not an ugly decimal. Okay? So that is one of the special relationships that you could have. The other one would be maybe instead of given the short part, what if you were given this longer part here as like a 4x plus 8, and you wanted to find out the longer part or the shorter part. Let's do the shorter part here. Let's just say that's 3x. Okay? So this short part isn't going to be like tripled to equal here. What you could do is you could take 2 times the short part, and that would equal the longer part. And the longer part is from the angle to the centroid. So that is going to be 2 times 3x in this case would equal 4x plus 8. That means 6x is equal to 4x plus 8. Subtracts the 4x. Subtract 4x, we get 2x is equal to 8, and x would equal 4. Okay? And we got one more problem. This one is going to be a little bit more difficult, but it is still 100% doable. Let's say that you knew this part here, this long one, this looks really long, so let's say it's bigger than 4x plus 8. Let's say that's 6x plus 10. Let's say you knew that part. You know the long part, but you don't know the short part. Let's just try and find the short part algebraically without finding an actual number. How could I represent this short part if I'm only given the long part? Well, I know this long part is twice as big as this short part. So if I wanted to figure out what the short part is, knowing that it's 2 times the short part equals the long part, I could divide the long part in half. So you can either distribute a half to 6x plus 10, or you can just divide both of those things by 2, which is the same thing, and get 3x and 5. Okay? And that is how you can get the short part. And then from there, you could do some other things. For instance, what if I was told that a all the way to, no, I can't call it an a, we already used a, q all the way to r, if q all the way to r is equal to, let's say, 10x plus, we'll do 10x minus 1, then you have two options. You could either add the 3x plus 5 and the 6x plus 10 to equal this, or you could again go to the 3 times the short equals the entire median. So I'm going to stick with 3 times the short equals the entire median. I find it a lot quicker. So that would mean that 3 times 3x plus 5 would be equal to the 10x minus 1. All right? So you could distribute the 3, and you could get your answer, and that's what I'm going to do now. 3 times 3 is 9x plus 15 equals 10x minus 1. I'm going to subtract the 9x over, and that would make 15 equals 1x minus 1. Add 1, and we get our final answer as x is equal to 16. And that covers all the variants that these centroid problems could give you. And they can get a little tricky, but you just got to remember 3 times the short part equals the entire median, or 2 times the short part equals the long part. And occasionally, you have to do what we had to do with the 6x part, where you have to take the longer part and cut it in half to get the shorter part. But that's pretty rare, especially with the x's involved. Okay? That's going to do it for today's episode. Until next time, stay positive, and I will see everybody later. Bye.